Hello everyone. I wanted to create a quick video to show you guys how to do question 3 on homework 7. Question 3 in your homework is a little different than what we kind of talked about in class, so I wanted to do a quick example. I'm pretty sure you guys can figure this one out. It's simple of solving for n, but I wanted to do an example for you. So this is very similar to the question that you find on question 3. Question is, if the population standard deviation is greater than 25, or is equal to 25, how large a sample is necessary to have standard error that is less than 9 points? So let's first look at our formula for standard error. We're going to focus on the less part later on, but let's first look at that. So what we have here is we have our standard deviation, we have our sample size that we're looking at, and we have our standard error. Now we know what our standard deviation is for the population because we have it up here. We know that we're looking for a standard error that is 9 or less, or I should say less than 9. So we're going to put 9 here. We're going to come back to how we get to less than 9 towards the end. So all we need to do is solve for n. So the first thing we need to do is move n out of the denominator. We do that by multiplying n, bringing it out, and bringing it to the other side of the equation. And so you end up with this. So square root of n times 9 equals 25. So obviously we still want to isolate n, and so we move 9 to the other side of the equation by doing the opposite. So we divide by 9. And we get n square root of n equals 25 over 9, which equals 2.778. Now a lot of people will stop here and think this is the correct answer, but remember, we want to get rid of this square root right here. So all we need to do to remove the square root is to square each side. So very simply, we can do the square root of the square root of n and square of 2.778, and we will get an n of 7.7160. Now it's important to remember that this would be a wrong answer if you just left it here, and here's why. We need to go back to remember what n refers to. N refers to the size of the sample. So it refers to individual people. So we can't have a fraction of a person in our sample. Also, remember, we're looking for the standard error that is less than 9. So even if we used this number as n, which we can't because it's referring to a fraction of a person, it would still give us the standard error that's exactly equal to 9. So for this reason, we will always want to round up. Even if we would otherwise, using our standard rounding procedures, we would round down. So for example, a number like 5.15, let's say we had an n of 5.15, we'd want to round that up to 6, because if we remember, larger sample sizes equal smaller standard error, and so if we rounded down, we would actually have a standard error that is larger than our target. So for example, so we would use this here, we use a sample size of 8. So let us take 8 and put it back into the equation and see what we get for standard error. So as you can see here, I put 8 down here for n, so that's our sample size we're going to be using. Here's our standard deviation. We do the math, and we get 8.8389. Now, let's just say that we decided to round down to 7. What would that look like? Well, it would look similar to this. Well, it would look exactly like this. So we would have 7 here, and we'd have a number that is larger than our target of 9. And so it's important that you see the difference and why we are rounding differently here, because we want to have a number that is less than 9. I hope that was useful for you. There's going to be a written version of this video, so a script of this video that is going to be on Angel. If you have any questions, email me at the email address you see below, and I will see you in class.